Welcome to the shop. I'm continuing to make the parts for NQALHA Production Run 4. There's 750 parts to make, so gotta keep at it. Today, I'm gonna be making some more small parts. These small parts, even though they're small, they still take time. Sometimes the tool change takes longer than the cutting cycle. But I'm continuing with the scheme that I've been working on, which is to gang up the smaller parts together. So I have a left and a right part in the vise, which kind of helps even out the vise pressure on the parts, because clamping a tiny little part on one side of the vise is kind of the jaws can twist a tiny bit, and this is a little bit more balanced. This is a known trusted tool path, but I've never run the gang version before, so who knows, there might be problems to solve. The blank is a piece of aluminum extrusion, and I cut it to size on the table saw, and as I said before, I have a high quality table saw, nice and rigid cast iron heavy machine, aluminum cutting blade, precision fence, precision whatever, trying to remember the name of the thing, but anyway, the table saw can actually cut, and a digital readout. The table saw can actually cut within a few thousandths and produce a decent surface finish. This part doesn't require a super cosmetic surface finish, and I'll touch it up a little on the Scotch-Brite anyway. So I'm going to start out here with holes. This is the bracket that holds the little circuit board at the back of the NQALHA, and it looks like, yes, it's stopping at the correct point, and stopping at the correct point. And that looks nice. Over to the second, and that looks nice. Looks like that's working. The little circuit board on the back of the NQALHA really doesn't have any electronic components on it, but it's just a handy way to organize connectors, the power connector, the foot pedal connector, and the connector to the cable harness. So there we go. We've got holes, and yeah, I was going to say they're not deep enough, but they are absolutely deep enough, because in the next operation I'm going to be milling this thickness down from 1/4 inch to 1/8 of an inch as I turn the part around and cut the clearance pocket, so that if you just have a circuit board with through-hole components with protruding leads and solder on the bottom, you can't just screw it down to a piece of metal or it'll short out. So there has to be a pocket cut in the part so that the various different leads can protrude through, and in the process of doing that, this piece is thinned out. So all is well. Going to turn off the cameras, run the batch, and come back for the second operation out of 3. First operation has been completed successfully. Like all of these more recent videos, I'm omitting a lot of the setup operations. I preload the tool carousel, the tool changer. I set the 0 using the Heimer indicator and the Tormach electronic tool setter for Z height. If anybody's interested in seeing how these operations are performed, they're explained in detail in the first several videos. First and second, I think, maybe third, I don't know. First for sure. So next operation is going to be to cut a pocket in the surface, the mounting surface where the circuit board screws down to provide clearance for the circuitry and the protruding through-hole pins, and also thin down this side of the extrusion because it doesn't need to be 1/4 inch thick. The jack for the foot pedal, the threads aren't long enough to put the nut on if it was left at full thickness. So once again, known trusted toolpath. Gang version has never been tried, but hey, we'll see. Yeah, the pre-feed looks a little odd, but let's go ahead and give it a try. Yeah? That actually looks correct. Being a little conservative here, because it is an unsupported vertical surface that gets thinner with every pass, and just going slow. This toolpath does work really well. Now I'm going to be hogging out the pocket. Everything is looking correct. Always have my finger on the stop button. But sometimes, in the wacky world of CNC machining, things go wrong before you can hit the stop button. Like I said, sometimes things go wrong before you can hit the stop button. Oh, okay. What the hell is going on there? Incorrect. This is extremely mysterious. The G-code looks correct. Wow. Looks like the toolpath program inserted a bogus work offset change to G55 that I didn't program in. Software can make you crazy. This one wasn't my mistake. Ah, yes. The joys of CAD software. So I cut and pasted the toolpath parameters from the left part to the right part and didn't check to see that the toolpath program had changed work offset. I don't know why. Since that part is already boogered, I'll go ahead and make sure everything works correctly before putting another part in. Looks like I have to cut another blank. Fortunately, I have plenty of material. Now, just a comment about toolpath software. The toolpath software I'm using, Bobcad Cam, is pretty good. It's inexpensive. It's basically what I can afford. A lot of toolpath software is just horrendously expensive. Astoundingly expensive. So okay, that's looking better. just amazingly expensive. And I can afford Bobcam, but it does have some quirks, limitations, and bugs. One thing that is almost good about it, it has a fairly good simulation feature. So before you actually cut metal, you can look at a graphic showing how the cutter is going to move. Unfortunately, looking good. The simulation graphic does not include work offset. And so, even though the system kind of like decided on its own to put in an incorrect work offset, the simulation just ignored that and showed a perfectly fine graphic of the part being made perfectly correctly. So, software will make you crazy. Didn't I already say that? Maybe it needs to be said again. Software can make you crazy. So now we got a 632 drill and tap operation for the mounting holes that mount the little circuit board. That's looking good, looking good, looking good. Probably doesn't need to be a full pack. That could probably be a fast pack. And of course, while the machine is working, I can take a moment to talk about the design philosophy of the NQALHA wiring. I don't use any splices or Y connections in the cable. I do what's called home run wiring. Let me make sure this does it correctly. Yes. So every single wire in the cable harness goes from a connector on one end to a connector on the other end. One wire, one connection. So there's no internal splices, Y connections, any of that kind of stuff. No soldered on connections. And this makes the cable harness a replaceable item. If one of them fails in the field, they can simply be unplugged with the connectors and a replacement can be installed. And of course, because of this design philosophy, I end up with a connector on a circuit board in the back of the unit where, yeah, I could just solder everything directly on. Let's verify that that's all looking correct. Everything looks nice. Ready to apply the tap magic. .632 holes are a somewhat troublesome geometry. I'm always a tiny bit concerned when tapping 632s. But looks like it's working well. The spiral flute tap ejects the chips up out of the hole, but I still like to kind of do my best to clear them a little bit more. Probably don't have to do this. And as I said in previous videos, if I get too aggressive on the trigger finger here, I can blow chips back into the hole, causing the tap to break. So, as with so many things in this project, I've come up with methods that work, that produce success. I'm not absolutely sure that I've got the absolutely best methods, All I know is that the methods that I use work. And I occasionally try to improve a little bit, but that's what the part looks like at this point. Then the next operation is going to be to put the part up and take a little bit off the edges to provide clearance so it'll slide into the back of the 1.5-inch square tube that forms the horizontal arm. And oh, too bad that little guy headed for the scrap bin. It's a sad day in Partland. So I'm going to go run the rest of the batch. Got another blank to make, another first operation to make, come back for the third operation, and then I'm just going to continue making little parts. I'm going to be probably doing 4 of them today, so little parts aplenty, all the little parts you can eat. Come and get it. Second operations have been completed successfully, including replacing the one boogered part. Here's how it fits together. And yes, it does fit correctly. Everything is just fine. So now it's time for the third operation, which is a fairly uninteresting operation. I think I'll get a spacer. I'm not sure I like. I think this guy is actually going to need a little spacer. I don't think I specified a spacer in the setup sheet, but probably a really good idea, given that this is a kind of an unsupported little floppy piece. So now I'm going to cut a couple of relief notches, hopefully successfully with no big problems. Work offset 2, checking to see that yes, it is correct. Stop talking when I'm watching. Last time I was talking about how you can't stop even if your finger's on the stop button instead of paying attention, and this caused me to not react fast enough on the stop button, so really need to stop talking when I'm doing this. Taking it very conservative here. Since this is, the part's kind of sticking out on the end of a thin piece, and it's not exceptionally well supported. So work offset still correct. I did do a cut and paste on this, so got another thing to check every time I a little bit of chatter. So, it appears that we have success. I'll go off camera and stick it into a horizontal arm just as a kind of a final sanity check before sending this batch of parts out for anodizing and plating. I'm going to do a kind of a dry fit. I'm going to assemble some parts together and just kind of put some on the surface plate, check them with measuring instruments, just in one last and final inspection just to make sure that I don't go through all of the effort or the cost and the time of getting them plated just to find out that they're incorrect when they get back. But hey, here's the part. Got its little relief over there. Got a bunch of stuff. Fits the circuit board correctly. Well, what a part. So, I'm going to turn the camera off, finish the run of these guys, and then come back and make another one. Really simple little guy, almost nothing to it, but even the simple ones are critical. You can't build an NQALHA without them. The little parts just keep on coming. Here's one that isn't that interesting. This is the vertical arm adjuster. Ooh, and it's got holes. Ooh. So, you know the drill. Somewhat known trusted toolpath. Gonna be trying for the first time the gang operation, cutting and pasting, trying to keep my eye on Bobcat to make sure it don't misbehave. It's going to be a fairly deep hole here, so I've got the longer drill in that has sufficient stick out. And I'm going to stop talking. Pay attention. Pre-feed height looks correct. I'm going all the way through the 1.15 inch block. Using a full peck cycle because chip clearance on this deep small diameter drill may be a problem. This block is used to adjust the NQALHA so that when the head is oriented in the vertical direction where the glass is perpendicular to the workbench, you can use the little set screws that are going into those holes to adjust the arm to perfect the perpendicularity of the glass piece, so you can have a vertical glass piece pressed against a piece of graphite and form an accurate Maria or other flat-bottomed feature. I'm not sure if anybody actually uses this, but it's there. Full peck cycle does take longer than fast peck, but for a 1032 tap drill going all the way through a 1.15 inch piece, I'm a little more comfortable with the full peck, even though, boy, it sure takes a long time. Everything looks like it's working correctly. Got no problems. These blanks were cut to size on the table saw, and once again, my table saw does a really excellent job of maintaining dimension, squareness, and surface finish. So, in the case of all but the most really critical parts, some of the parts that I make, I just cut them roughly on the chop saw. Surface finish is okay, but then I mill the profile, so the cut surface just goes away in chips. Most of the parts that I need cut to size, I make on the table saw. But if I really, really need it to be, you know, as accurate as I can make it in the shop, I'll cut it roughly to size on the chop saw and then put it in the Bridgeport and get the faces as good as I can do on the Bridgeport. So here comes the end of the drill operation. Looks like it completed successfully. Then I'm going to be power tapping, and the tap doesn't go all the way through, obviously. It doesn't need to, and it's not that long, so I'm only tapping about halfway through the hole. And it's stopping in the right place. Gonna get the all tap magic. Lube up the holes. Tap magic for aluminum, as I've said many times, really is magic. Touchscreen is not as good as I'd like it. Sometimes I don't like touchscreens in general, but problem with touchscreens in the machine shop, the typical technologies for touchscreens, the capacitive technology, just don't work well with chips and coolant. Not even close. And so I'm using the older technology, the resistive technology, which is actually about the only one that actually works reliably in the machine shop. And I shouldn't say reliably, a little bit more reliably than the capacitive one. So there we have holes all the way through. Going to run the first operation, run all the parts, turn the camera off, come back for the second operation, which is only half as exciting because the second operation is just one hole instead of two. Bet you can't wait. First operation has been completed. Now the parts are flipped over. Same work offset, same zeros, 0 on the bottom of the part. Now I'm going to be drilling and tapping a hole. Holy hole, Batman! Okay, stopping at the right pre-feed. Everything looks correct. No work offset problems. Holes are happy. Time for the tap. Quarter 20 tap is a pretty strong tap. I don't have to be anywhere near as concerned as I am with the 632s, but I still use the tap magic and still pay attention. Yeah, looks like this tool path is fine. I'm going to go ahead and finish up the run. Deburr them a little with the Noga. Knock some of the saw cut off with the Scotch-Brite. And there we have it. So when I come back, there's another little part and then another little part. Actually, the last one is somewhat more complex. The next one is super simple. The little parts, I'm starting to get to the end of the little parts. This will be the last video of the little parts. And after that, the parts get a little more interesting. They're going to be using different processes, and even the kind of sort of CNC lathe attachment for the Tormach that, you know, it's not a very good CNC lathe, but it is a CNC lathe, and it does the job. So That'll be interesting. This next part is not an interesting little part at all, but it does have a kind of an interesting history. One of the earliest NQALHA users, I was watching him work, and I noticed that when he moved the clamp body up to the top of the clamp bar, it was binding. And I told him, hey, I can fix that for you. It's not supposed to be that way. And he says, oh no, I like it, dude. I like being able to just move it up to the top and have it stay there. And I thought about that for a moment and realized that, well, you know, doing it with binding is never going to work because it's binding wears out. So I came up with the idea of using a little neodymium magnet and a little steel magnet plate, and that is now part of the design. I kind of snuck it into version 2.2 without bumping the version number, so version 2.2 units have it. This is the little aluminum block that holds the magnet, and it's not very interesting, but you know, gotta have it. Same as before, gang operation, 2 parts in the vise. But I also usually give it just a bit of Loctite retaining compound. So, hey, look at that. Holes! So, you know the drill. I'm going to turn the camera off, run the batch, and then be back for the second and third operation. Ooh. So now it's time for the second operation. This is a through hole and a countersink. Boy, these little parts are uninteresting. Because I'll be milling away a rabbet in the opposite side, and then when it's all done, a through hole. Here comes the counters. 600 RPM, 5 inches per minute. The solid carbide countersink. And it's kind of easy if you get too aggressive countersinking aluminum. It's very easy to get the material to weld onto the flutes of the countersink. So, boy, not a very interesting part at all, but no, it's a useful part. Helps out a lot. Okay, third operation will be to mill a rabbet and then on to the last little guy for the day, which is slightly more complicated. It's a little part that most of the material gets milled away and there's not much left to hold on to. So here we go. So the second operation was finished, and that's no surprise because it's easy. Now it's time for the third operation. This is going to be cutting a kind of a rabbet using a 1/2-inch end mill, and it should go fine, but that's what I always say right before it goes wrong. So once again, gang-loaded parts. I've switched to soft jaws with a very, very small ledge This ledge is a little over 1/8 of an inch because I'm going to be cutting away most of the material and leaving, I don't know, a little under 200 thousandths, like 190 or something. So don't want to hit the vice jaws. Let's see how it goes. And, yes, the old half-inch end mill flings the cutting fluid. Find out if it works. Doing it in 2 passes. And I believe I have success here. So there's the part. Not very exciting, but necessary. So I'm going to run these guys, and I don't know, I'm kind of getting tired of working today. I might take a little time off and not make the 4th part. I don't know, maybe. Yeah, I think I'm not going to make the 4th part. Make the 4th part tomorrow. So, thanks for watching. It's been fun.